Okay, we've got our, I might have called it a spindle, but it's really just a shaft. It'll be stationary. We've got it machined, and for this end over here, I just went over to the surface grinder. I took a 3/4 inch, I'm sorry, I took a 1/2 inch fender washer and bored it out enough for this 3/4, and then went to the surface grinder and be sure it had a good flat surface on both sides. But this is going to mount on the 2x72 belt grinder. Before I show you how that's going to mount, let me say a couple things about the grinder. This is of course shop build. I've got a complete video series on this build. I call it a reverse build. I start with the finished product and then show you how each piece was made. But if you watch that series, or if you later watch it, you'll see in it where I had a motor set over here with a pulley, small pulley going to a large, with a large pulley going to a smaller one that was set on a couple of, a shaft on a couple of pillow block bearings. And that motor was, I don't remember now whether it was a 1/4 horse or a 1/3 horse, but it was no more than a 1/2 horse. And I couldn't get the RPMs I wanted out of it, and it didn't have the power, and it was very easy to stall it when I was sanding or grinding with this. So I did away with all that. This is a 2 horsepower, 3,450 RPM. It's an 8-inch wheel on the motor. So 8 times pi, 3.14, is 2512 times the 3,450 RPMs, 86,664 divided by 12 inches per foot, have a surface feet per minute of 7,222, which is a seems to be a very good speed on there. All right, I'm going to unplug it now while we're working with the belt, changing the belt. We'll take the belt off now. The platen itself will come off, and the work surface here will come off when the wheel is installed. The wheel is going to be mounted on a piece of this tubing, just like the platen is, and could be mounted on the same one, but I want this all to be quick change. So I've got another piece of, I picked up a 3-foot piece of this 1 3/4 inch tubing, and it will slide in here just like each of the other pieces do, and any other accessories I may make. But again, in the previous video, in the build video, I pointed out that this tubing has a inside weld, and the material will not go in there with that weld in place. So what we're going to do now is take this new piece, carry it over to the mill, and I'm going to do the same thing to it that I did for this. Hopefully you can see in there there's just a shallow track, just enough for that for this weld joint to pass through. So I'm going to get that laid out on where it needs to be, and then we'll go back over to the milling machine. Over here at the milling machine now, I've got our piece of tubing mounted in the vise. Got a jack under this end down here to help support it. We're not going to be taking very much off at all, but of course we don't want it moving on us either. So let's get this down to the end. On where the weld joint was, they're not in the center. When I was building the 2x72 to begin with, I had to measure each one, or mark each one of the male-female pieces, again, because that weld joint is not in the center. So let's touch off here. And we'll set our DRO right there. All right, that's about 40 thousandths. I think that will be sufficient. And I'm gonna mill this slot out for about 8 inches. I won't have that much of it sticking in, but I want to be sure I've got plenty enough. Tell you what, let's get a little higher RPM there. All right, there's 8 inches. I'm going to carry this over to the, back to the 2x72. Going to deburr that first, carry it over there. If it fits, if everything's fine, I'll meet you back over there. I may have to bring it back over here and mill off just the top of, just a little bit of this edge. I'll just see how it fits, and then we'll get ready to mount the wheel on it. Okay, the groove we cut in there appears to be in the correct location, and I'm sure it's plenty deep enough. But the piece just won't, excuse me, just won't quite slide in yet. Looking back at the platen arm and the work holding platform, I can see where I actually did some milling down on them before. So I'm going to try this fly cutter now and come down and take about 10 thousandths off of two perpendicular sides. Try that. If it still won't quite go, I'll get 10 thousandths off the other two sides. So let's try this now. I've already got my fly cutter zeroed out. So there's about 10 thousandths. Let's see how this works. I've never used this fly cutter. Again, I could have forced it in, but I want it to slide in and out easily enough so I can adjust the tension on the belt. Face mill appears to be leaving a pretty good finish. Not quite as good as I had hoped, but again, this is just mild steel here, I'm sure. All right, I'm going to rotate this 90 degrees, run another surface on here, try that, and keep going again, cutting off just a little bit at a time, milling off a little bit at a time until I'm satisfied with it. Then we'll meet back over at the 2x72 and determine where our wheel needs to be mounted. Okay, to get this to work smoothly in there, I actually carried it back with the face mill and did all four sides. And the biggest culprit was the corners on here. I needed to round them off a little bit more, take just a little material off, but it slides good now. Remember, this will be stationary during operation. What I want to do, though, is mark off on the side, that'll be the top. I'll mark about 7 inches here. That way I know I got plenty of material up in here. I'll tighten this down. Now what we want to do is try to hold the belt up here to get an approximate location for this contact wheel. It's going to be stuck out here pretty far. All right, so right along there is where the center needs to be, or where the hole needs to be. So I'm going to get turned around to the drill press, and we're going to put a 1-inch hole in there. I need to get some drill bits over here, but we'll put a 1-inch hole all the way through. Okay, I think I might have said a 1-inch hole, but it'll be a 1/2-inch hole. And over here in this part of the tin barn, I have this Skill, supposed to be drill press. This is from came from Lowe's several years ago. It's almost worthless, folks. It doesn't have any power, but But I got it set up here. Next yard sale, that's probably what it'll probably be on it. We're gonna try to at least drill this one hole. I was bottomed out on the quill itself. Okay, let's try that. Now we'll put our 1/2 inch in. Sorry if I'm blocking the camera, but I don't have a lot of working room right here, or where I've got to reach to. As you can see, get much over a 1/4 inch bit, and it's very easy to saw. Okay, folks, I'm gonna go in there to my other drill press, which is the same size as this, but it's about 50 years older than this one, and get that hole drilled, and I'll be right back. Okay, now that we got the hole drilled in there on both sides, let's go ahead and mount this arbor. Then what I want to do is mark off where this needs to be cut to length. All right, I think the only thing that's left is to cut this off and then to assemble everything and check the tracking. So I'm going to step over to the to the bandsaw, saw this off, then we'll come back and do a test fit on it. Well, my friend over in Texas at the Amateur Redneck Workshop says every project starts with the bandsaw. In this case, every project, or this project's going to finish with the bandsaw, pretty much to finish. Okay, we're sawed off now. I'm going to deburr this some, clean it up, degrease it, and paint it. Then we'll be ready to assemble everything, get it tracking properly. All right, I'm gonna go give this a freshwater rinse, give it a paint job, and like I say, then we'll come back and assemble. Okay, I think our paint is dry. We're ready to put this together. Before I painted it, I actually took my center punch, put me a couple punch marks down there, just as a reference of where to lock this down. So we've got that in. We'll take our 1/2 inch bolt, run through, and I'm going to put a little thread lock on this. And this is our spindle, arbor, bearing shaft, whatever we want to call it. And I have my slick jaw vice grips here. Now we'll slide our wheel on. Remember, this shoulder right here is going to mount against this inner race of that bearing. And then this shoulder washer we made will ride on this, on the outside of this inner race as well. And I realized something as I was painting this, that the belt is going to be turning that way, which would constantly be putting pressure on this to try to loosen it. So what I did off camera was drill and tap this 3/4 inch nut for a 1/4 20 set screw. So once we get this in and tightened on there, and I'm sure it boogered up those threads just a little bit. All right, I'm gonna have to clean up those threads. I'll be right back. All right, I didn't have a 3/4 inch tap to chase those threads with, but this is a grade 8 nut, and which is, I'm sure, harder than this mystery metal we made our spindle shaft out of. So I simply mounted this in the vise and used a grade 8 bolt to chase the threads with. And any wrench I've got over 1 inch, which this is 1 1/8 I believe it is, or maybe 1 1/16. But any wrench I've got big enough for this is over at the farm on the tractor, or with the tractor tools, so use a pipe wrench. Now we got that close by. We'll get our set screw back in, and I'm going to put a little thread lock on that as well. All right, we got that started. Now we'll tighten it on down. We don't want this super tight. We don't want it binding by any means, but we want it tight enough against the inner races so that it holds the race and the bearings turn instead of the race turning on the spindle. And we'll tighten that down pretty good. All right, we're ready to put a belt on now. Check our direction. This is a directional belt. Let's get her plugged back in. I'm just going to jog it to begin with. May need to work with my tracking up here just a little bit. I don't know whether you can see it in the camera or not, but it's riding about 1/8 of an inch over on the wheel. If this doesn't correct it up here, I'll simply take this spindle back to the lathe. Excuse the camera move right quick, but I want to show you what I'm talking about. This distance right here is what I kind of had to estimate based on where the platen was setting as far as what that length would be. If I can't get this tracking perfectly with the tracking wheel up here, I can simply carry this back to the lathe and take just a little bit off right here so it sets back in here. I don't want to take it out of the part that the bearings are riding on, because that is all the correct length. But I think it's going to work fine. Should be able to sand concave surfaces now, larger concave surfaces. I will more than likely in the near future pick up a 4-inch wheel as well and do the same thing with that. But I hope you've enjoyed this video and got a little bit out of it. We'll see you on the next one.